Okay. Well, welcome everyone, and welcome to the BIS tonight. Thanks for being here. A few housekeeping items. We're not planning a fire drill, but if there is a fire at the back of the building, we'll leave through the door front of the building you entered with. And our assembly point is the entrance to Vauxhall Gardens, which is about 77 paces to your left on the street. So you'll see that. If there's a fire at the front, we leave at the back door. That's going left out of the doors of the room here, out of the door, into the door, through some gates, onto the road, and then left. Yeah, that's housekeeping. The event tonight is our new format, Fireside Chats. And tonight we are Bepi-Colombo, Europe's journey to mysterious Mercury, with Professor David Rothery and JerryStone. So I think I should hand over to Jerry. So thank you very much. Thank you.
Thank you, and welcome to everyone here, and those of you online who I believe for the first time may be the maximum number that we've had for one of our hybrid events. So obviously welcome, David, and I'd like to start off by asking you about your background.
Well, interestingly enough, because of the name of the building we're in, I grew up reading Arthur C. Clarke's science fiction. But I was also in the Birmingham Astronautical Society as a teenager. I went to Cambridge to take a degree in natural sciences, expecting to be a physicist. Found that the maths he had to do physics was too much for me. But because the beauty of Cambridge is it's a tripod system, you do 3 different sciences to begin with. I tried geology in my first year and stuck with that. So rather than becoming an astronomer, I became a geologist. My PhD was using satellites to do geological mapping. So I was looking down on the Earth rather than looking out to space. Yeah. And I kind of migrated from monitoring volcanoes on the Earth from satellites to looking at other planets. So I'm in the, broadly speaking, astronomy, certain planets, an unexpected route.
Thank you. So, as the main subject is the Bepi-Colombo mission, the first obvious question is, how did it get its name?
Okay, there are not many spacecraft named after people. One was Cassini and Galileo, but this is named after a person who was living in recent memory. It's named after Giuseppe Colombo, who was an Italian astronautical engineer. And most of you have probably heard of Mariner 10, mission to Mercury, the first mission to Mercury in the mid-70s. And the original idea was just to do a flyby of Mercury, but Giuseppe Colombo said, look, if you swing past Venus, you can get there more economically. And also you can put a probe in an orbit, which takes twice as long to go around the sun as Mercury goes around the sun. So when you completed one orbit, Mercury is about to overtake you. So you can have multiple flybys. So Giuseppe Colombo invented the swing-by maneuver, later used to get Voyager around beyond Jupiter to Saturn. And he also engineered multiple flybys for the price of one with Mariner 10. He had 3 flybys before he ran out of manoeuvring fuel. So we had 3 visits to Mercury from Mariner 10. And there was a pet name for Giuseppe's Bepi. It was Bepi to his mates. So when the European Space Agency agreed to have a mission to Mercury and they were looking for a name for it, we called it after Giuseppe Colombo. So it became Bepi-Colombo. One word, capital C in the middle of it, Bepi-Colombo.
So, as you said, we previously had Mariner 10 on that, but why is Bepi-Colombo taking so long on its journey to get into orbit?
We'll come to the long journey in a while, perhaps, but the planning process, it was 93 or 94 when there was a proposal put before the European Space Agency to send another mission to Mercury. There'd only been the one, the flyby mission. It's only seen half the planet. So the argument was it's high time to go again. And I wasn't involved in this at all until about a month before the meeting with at ESA headquarters in Paris. It was called. John Guest was not able to go. And somebody said, see, Dave will go. So I was recruited to this team to make the geological case for that Mercury. The prime movers were geophysicists who wanted to study the planet's magnetic field. The Mercury's magnetic field, which we may come on to, is very special. No other rocky planet has a magnetic field apart from the Earth, Mercury. So there's a lot of, I mean, it's very interesting going to Mercury, but the geology was thought to be fairly boring, and I thought it to be fairly boring as well, but I saw it as good as well as I could. Anyway, 7 years later, ESA approved the mission. In the meantime, NASA also approved the mission, which is Messenger, which got launched in 2004 or something, and then completed its mission in 2016. So they were much quicker with getting with the approval process in NASA. But ESA in the year 2000 agreed to have a mission. It was going to have a lander, which was dropped a couple of years later. And then it took a long time to build. There were physical constraints. It was going to go in a Soyuz frigate that wouldn't fit inside the fairing in the end, so it had to go on an Ariane. And the thermal design was very complex as well, because if you're orbiting Mercury, you're 3 times closer to the sun than you are here. So that's 10 times the solar heat effectively. It's very hard to keep it cool. So the thermal design took a long time to get right. So it was a long time getting ready for launch. And then when it was launched, the idea was to have an 8-year cruise. It's simple to get to Mercury if you don't want to stop when you get there. But if you want to arrive, say, and go into orbit, you've got to match velocities with Mercury. So you've got to be slowing down all the way, fighting the sun's gravity, so there's not to arrive there too fast. So our cruise, we've got a video which will show the cruise in Earth. So it took us out beyond the Earth, and it came back in for an Earth swing by, and then 2 Venus swing bys. And we've had 6 swing bys of Mercury. And we're now tracking Mercury around the sun. So we've got the same orbital period of Mercury, which is just got to adjust our orbital inclination and our perihelion and aphelion to completely match Mercury, so we get captured into orbit around very low amounts of fuel to run the action. And that was meant to take 8 years. In fact, it's taken us 9 because our propulsion is not working fully up to spec. It's solar electric propulsion. We've got solar panels on the transfer module, generating electricity from the sun. And our reaction mass is xenon, very heavy nucleus, and the ionized xenon is our reaction mass. So it's lower, what's the word? It's, you can get a large delta V, but it takes a long time to build up. It's that low impulse, the right term. Anyway, there's something wrong with the solar power generations and microfraction wires. So we're working right at the margin of the efficiency, hence the extra year before we can achieve orbital insertion. So it's a long cruise because you've got to do it right and arrive at the right speed. It's taken us a year longer because of propulsion connection.
And that's a major thing, but it's because you have, rather than going out to the outer planets where you increase your velocity, there is so much velocity that has to be lost. And an extra year means Mercury's gone around the sun another 4 times in that period.
Yeah.
Yes.
We are very clever people at ESA that tackle this in astronomy. I don't think they missed the beat, really.
So how did you actually become involved?
Well, after I did my bit in Paris making a geological case, I thought that was it. But it was a couple of years after ESA had approved it, but the strawman payload was announced, and the people bid to build the instruments to match this strawman payload. So most ESA subscribing nations had groups within them that put in bids to build instruments. And how it works in the UK, it's probably similar to how it works in other countries, is there's a project peer review convened by PPARC in those days, Particle Physics and Astronomy Research Council, it was then. The PPARC received these bids. There were 2 bids to build an X-ray spectrometer, and there was a bid for an infrared spectrometer and a bid for a magnetometer as well. And on the panel, I was invited to be on that review panel. And we said, this is important, Britain should be involved, we've got the capabilities, and we recommended that 2 of these instruments will be funded by the UK. But usual story, isn't it? There wasn't enough money. There wasn't really enough money for one instrument. It enabled in the end. And the one instrument that was approved was an X-ray spectrometer, which ended up being designed, run from, partly built at Leicester University. So I was put on the oversight committee to ensure that this instrument was being built to spec and we would perform the science goals we wanted from there. And then I was asked to switch teams and actually be on the instrument team. I think the view from the Research Council was, got people who can build the instrument, we've got X-ray astronomers, they haven't got a geologist who understands what they'll be using it for around such a planet. They put me, so I was a poacher that got turned into a gamekeeper the other way around. And that was great for me because I was now on the instrument team. And I've been there while they were building and designing instruments and we're setting the science goals. And they put me on the Bepi-Colombo science team, so I've been very deeply involved in all the surface-looking science that Bepi will be doing.
Well, you also mentioned the magnetometer, and that's an area of interest of David Southwood, who did the magnetometer for Voyager. Was he involved early on?
No, he was the Director General during the part of this project. Yeah. But I never saw him directly involved in the Bepi-Colombo project. But yeah, I mean, the magnetometers are clearly a big thing for Bepi because
it has a magnetic field, unlike the moon, for example. Yeah. So, what are the main goals of the mission?
Yeah, well, there's a long list, and we had a long list of goals, which was written at the same time as the list of messengers' goals. Because Messenger's been there and done its job.
Yeah.
So our goals have evolved since then.
Right.
So we didn't design the spacecraft to answer the goals that we now have.
Mm-hmm.
But that's okay. I mean, obviously, we'll stick with magnetometers for now. To generate a magnetic field, you've got to have an electrically conducting liquid that's in motion. You need a magnetic dynamo to be operating. And you can't have a lump of iron that's magnetised. It's going to be too hot inside the planet to be a permanent magnet. You've got to have a dynamo action going on. So the outer part of Mercury's core, like the outer part of the Earth's core, is in some kind of motion. Probably not driven by the planet's rotation because Mercury rotates slowly. There's probably some thermal convection making churn around. Anyway, it's generating a magnetic field. It's a dipole magnetic field similar to the Earth, though not symmetrical about the equator. And the way this interacts with the solar wind is of great interest to solar wind physicists and magnetospheric scientists. There's all kinds of field lines being broken, reconnecting, and they need to tackle stuff and so on. And magnetic substorms. I'm coming over those terms, which I don't understand. But these things go on a smaller scale and a lot quicker than they go on in Earth's magnetosphere. And this kind of space weather, it's kind of thing that's winning. Yeah, it's violent, knock out telecommunications. So studying these processes at Mercury is quite illuminating. And we've got 2 spacecraft on there. There's the European one, which is going to end up being called Bepi-Colombo, I suppose, when it's in orbit. And there's the European, there's the Japanese spacecraft. It used to be called the Mercury Magnetospheric Orbiter, MMO, but the Japanese renamed it MEO a few years